Okay, this is the question. The question is, the ends of a line PQ are on the same projector. That is, there won't be separate projectors for P and Q. Only in the same projector P and Q are coming up. P is 25 millimeter below the HP and 30 millimeter behind the VP. That means below the HP and behind the VP, it is in the third quadrant. P is in the third quadrant. The end Q is 50 millimeter above the HP and 40 millimeter in front of the VP. Q is 50 millimeter above the HP and 40 millimeter in front of the VP. That means it is in the first quadrant. Now, what we have to do is show the projections and measure the true length and true inclinations of the line. This is a special case in the projection of lines. That is, both the ends have the same projector. This sort of problems comes up when the sum of theta and phi becomes 90 degree. If you have noticed till now, in none of the problems, in none of the exercises we have done, the theta plus phi angle was never equal to 90 degree or more than 90 degree. If in a question, if it happens that theta plus phi is more than 90 degree, that is an impossible situation. Theta plus phi can never be more than 90 degree. The maximum possible value for theta plus phi is 90 degree. And that particular special case is given here. Theta plus phi is 90 degree. When theta plus phi is 90 degree, both the projectors will coincide. And in such a case, the line will be lying in a profile plane, that is in a plane which is perpendicular to both HP and VP, and hence it will be the projections will be perpendicular to XY line. Both the projections will coincide, and both the projections will be perpendicular to the XY line. That is this special case. This is the case when theta plus phi is equal to 90 degree. If it is, if in any case, if theta plus phi is more than 90 degree, if it is given like that in your question, then that particular question cannot be solved because theta plus phi cannot be more than 90 degree. In that case, one of the angle you have to reduce so that at the maximum it can be 90 degree. Suppose if it is given that theta is 45 degree and phi is 55 degree. So 45 plus 55 is 100 degree, which is not possible. So in that case, what you can do is you can reduce the 55 degree to 35 degree and solve the question. Maybe it is a typing mistake, or maybe some other concept, or it was not the phi that was 55 degree, maybe it was beta that was 50 degree, 55 degree. So that sort of mistakes may happen in your question papers from the university. That used to happen when it was MG University, but nowadays it is slightly less, that sort of mistakes in the question paper. But if such a sort of mistake happens, then what you have to do is you have to rearrange the value so that the value, the theta plus phi, becomes less than 90 degree. That is, then solve it. You cannot say that this cannot be solved and hence I will get mark. No, you won't get any mark for even if you write it as this cannot be solved using this particular values. So in this case, both the end projectors are in the same line. So let's see how it is being solved, or how this can be solved. So the base figure doesn't have any meaning here, or because all the projections are already there. So first we draw the XY line, then we draw a single projector. Because all the 4 points are lying in the same projector, we need only one projector here. So this is the projector, and now we know that P, the point P is 25 millimeter below HP, so the P dash will be 25 millimeters below the XY line. So P is marked 25 millimeters below the XY line, and then P is 30 millimeter behind the VP. So the top view P should be 30 millimeter above the XY line. So this is it. P is 30 millimeter above the XY line. Now the end Q is 50 millimeter above the HP. So Q dash will be 50 millimeter above the XY line. Q dash. Then Q is 40 millimeter in front of the VP. So that means the top view of Q will be 40 millimeter below the XY line. So Q is there. So now you can join P dash with the Q dash, P with the Q. Even if you join P with the Q dash, P with the Q and P dash with the Q dash, it will be as the same straight line which is joining Q with the Q dash. Only single line will be there since it is a perpendicular line. Now what we have to do is we have to find out the true length as well as the true inclinations. In order to find the true length, as we done in the previous case, we drop perpendicular lines from P and Q. This is 40. From P and Q, we draw perpendicular lines. And in this case, since this particular PQ line is perpendicular to XY line, the perpendicular to this line will be parallel to XY. So because perpendicular to a perpendicular will be parallel. So that is this line. Then P2 and Q2 is obtained and join P2 and Q2. So this will be the true length. P2, Q2 will be true length. And in Q dash and Q also, you draw two perpendicular lines. And in this case, see the perpendicular lines are in the opposite directions. Pardon?
P2 length.
P2 length is the distance of P dash from XY line.
Okay, sir.
The distance of P2 will be equal to the distance of P dash from XY line. Q2 will be equal to the distance of Q dash from XY line. One thing. And the other thing, have you noticed that the P2 line is towards the right of PQ and QQ2 is towards the left of PQ? Why is it so? It is because P dash is lying below the XY line and Q dash is lying above the XY line. That is in the opposite sides of our reference plane. So that's why we are taking it towards the different sides. If such a thing happens, that is both the endpoints are in two different quadrants, that is it crosses the reference plane, then in that case, it has to be in two different quadrants. I mean two different sides of the original projection. So P2 is towards the right of PQ and QQ2 is towards the left of PQ. That is why is it so? Because P dash is below the XY line and Q dash is above the XY line. So obviously the traces should be lying in between this PQ and P dash Q dash. In between that particular line itself. There is no other way we can find out the traces of the line other than this rotating plane method. In this particular case. In this particular case means when both the projections are perpendicular to the XY line, in that case, there is no way you can find out HT and VT in our conventional method, that is in our plane line rotation method. There we cannot find out the HT as well as VT. In using only this particular method, you can find out HT and VT here. And at this point will be our HT. This point will be our HT. This point. And this inclination will be theta. So that is the condition. That is how you can find out HT and VT in the case when both the projections are perpendicular to the XY line. Now, true length is found out for the top view, that is P2, Q2 is found out. Now we want to find out P1, Q1. P1, Q1 is found out by using this, from Q dash you drop a vertical, perpendicular line to P dash, Q dash, and from P dash also you drop a perpendicular line. And the distance of this perpendicular line, that is the distance of P dash to P1, P dash to P1 should be the distance of P from XY line. That is this distance, this P to XY distance. And the distance of Q dash to Q2, I mean Q1, Q dash Q1 will be the distance XY to Q distance, XYQ, this distance. So then join Q1 and P1. Now in this case, it is approximately HT and VT are coinciding at the same point. I am not sure whether it is coming like that. Without drawing it, I cannot say it. But this, when P2Q2 intersects with the PQ line, it is HT, and when P dash Q dash intersects with the P1 Q1, it is VT, like here. Here A dash B dash is intersecting with the A1 B1, so that is VT. So this is VT, and here it is HT. So when P2Q2 intersects with the PQ line, it is HT, and when P dash Q dash intersects with the P1 Q1, it is VT. I'm not sure whether both this HT and VT are the same. You just verify whether it is same. Now this angle is theta and this angle is phi. This angle is phi. So that is it. I hope this is a very simple drawing. Only 4 lines are there. And the dimension lines, only 4 lines as well as the dimension lines are there. So I'll explain it once more. First you draw the XY line, then a perpendicular line, that is the projector for P and P dash, I mean P dash, Q and Q dash. In that one you mark the P dash as well as P, then Q as well as Q dash as well as Q. Then you join P with the P dash, Q with the Q dash, I mean P with the Q and P dash with the Q dash. That will be the same line. Then draw perpendicular from P and Q, and the distance of this perpendicular will be from on P, the distance will be the distance of P dash from XY line, that is 25 millimeter, and on Q it will be the distance of Q dash from XY line, that is 50 millimeter. And in this case, both P dash and Q dash are on opposite sides of XY. So the perpendiculars should also be on the opposite sides. That is, if P is the perpendicular on P is towards the right, then the perpendicular on Q should be towards the left. And the reverse is also possible. If you are drawing the perpendicular on P towards the left, then the perpendicular of Q towards the right is also possible. But it should be on both sides, on the opposite sides of P and PQ. By using this, you obtain the points P2 and Q2, then join P2 and Q2. And the angle between P2 and Q2 and PQ will give you the theta angle, and the point of intersection of PQ with the P2, Q2 will give you the HT. Now, from point P dash and from point Q dash, draw 2 perpendicular lines. Similarly, in the previous case, it should also be in the opposite sides. And in the distance of the perpendicular in P dash should be the distance of P from XY line, that is 30 millimeter, and the distance of the perpendicular at Q dash should be the distance of Q from XY line, that is 40 millimeter here, and then join these 2 points to obtain the length of the true length. The true length is P1 Q1 as well as P2 Q2. Now, the inclination, the angle between P1 Q1 and P dash Q dash will be phi, and the point of intersection of P1 Q1 with the P dash Q dash will give you the VT. So this point is VT also. I'm not sure, as I said, I am not sure whether both HT and VT are coinciding here.
Sir, coincide is
Coincide is an analytic. Okay, that's good. ഓക്കെ തീറ്റ പ്ലസ് 5 90 തന്നെ കിട്ടുന്നുണ്ടോ?